On today's episode, NASA is testing the Dream Chaser spaceplane for International Space Station shuttle missions. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. If you want to visit the International Space Station, there are two ways to get there: by Dragon spacecraft or by the Russian Soyuz system. A third option, Boeing Starliner, has flown an unmanned test as part of a NASA space station resupply contract. NASA itself has the Orion spacecraft, although this is primarily designed for lunar and deep space exploration. These systems are about to be joined by a fourth, Sierra Nevada Corporation's Dream Chaser. Developed under a NASA station resupply contract, the first flight article is complete and ready for delivery to the NASA Armstrong Research Centre for testing. Why a fourth crewed spacecraft for ISS transportation? Well, it's part of a long-range NASA goal to increase competition in the commercial space industry and to provide redundancy to ensure uninterrupted station operations. Dream Chaser has been in development for years, but compared to the traditionally shaped capsules of the other systems, it's much more like a miniature space shuttle. The Dream Chaser spacecraft has successfully completed its approach and landing test, demonstrating the spacecraft's ability to glide back to Earth and land safely. The reusability factor is expected to drive down the cost of space missions, and current plans call for at least a 15-mission life expectancy for each airframe. Dream Chaser can carry up to 5 crew members or a combination of crew and cargo, but compared to capsule-based systems like Dragon and Starliner, the lifting body shape of the spacecraft and its aircraft-like landing mode allows easy recycling of the vehicle post-flight. And with a cross-range capability of about 1,000 miles, it will be relatively easy to divert Dream Chaser to alternate landing zones if necessary. Staying in orbit for an extra day to avoid weather may become a thing of the past. Another potentially important benefit is the low G loading generated by the Dream Chaser re-entry profile, as low as 1.5 Gs. This may be important for sensitive scientific experiments returning from the ISS and has obvious implications for space tourism. Lifting the spacecraft into orbit may be accomplished using several different launch vehicles, with initial launches atop Falcon Centaur, with a version under development to integrate with Orion space launchers. Dream Chaser represents the fourth crewed spacecraft for the United States alone, in addition to Russian and Chinese capability, and India is expected to launch astronauts soon as well. Will human travel to Earth orbit become commonplace? Well, not yet, but Sierra Nevada Corporation's Dream Chaser is the vehicle that's the closest yet to airliner-type operations. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.